Hello, my name is Dmitry. I'm a researcher at Knowledge Lab, and today I'm going to talk to you about a recent study in the field of virtual reality education. We looked at the literature and found it to be very inconclusive to the point that one could say that virtual reality training is as good, or at least not worse, than any other types of training, which is a bit surprising because virtual reality has a lot of uh, unique features that could enhance, in theory, education, at least in some fields. So why is that happening? Um, and the most obvious answer is that one should design the training in virtual reality accounting for what makes virtual reality unique and special from the ground up. And it's not done very often. So there are two factors that are most often uh, agreed upon in virtual reality education, and one is that virtual reality has a positive motivational effect, so students want to participate in learning. But at the same time, virtual reality comes with the risks of a lot of distractions. So maybe your student want to play in VR but not doesn't want to learn. And those are related, so you can't just remove all the distractions because then you would lower the positive emotional effect from virtual reality, and you don't want that. So, this reasoning was done within the cognitive load theory framework and the model of multimedia learning. Cognitive load theory says that there is an intrinsic cognitive load that is related to the complexity of the material itself, and then there is an external cognitive load that is all the unnecessary distractions that could be removed from your education and should be removed to make it better. So all the distractions uh, fall in the category of external cognitive load. And we propose that there are some sources of external cognitive load that are specific to the virtual reality. And within those VR specific sources, we want to talk about one that is often mentioned but really understudied as far as we can tell, and it is the prior experience of our participants with VR. So if you have to learn the virtual reality itself and some other material at the same time, you're probably not going to do well. So this was the focus of our study. We wanted to see if adding some sort of an adaptation phase before learning in virtual reality would improve the educational results. At the same time, we wanted to see if this adaptation has to be similar to the training environment, or it could be anything. And we wanted to see if cognitive load actually related to those effects. In our study, we have just above 100 participants. They were divided into three experimental groups. So one had a generic adaptation, so-called, which was just a VR game. Then we have a specialized adaptation that was very similar to the one we used in our education later. And there was a control group with no adaptation. So education in our study was for middle managers who learned the corrective feedback skill. Corrective feedback is a type of feedback given to the employee when some changes in their behavior are desired. And we used the step-by-step learning program where we had a complex skill. We divided into small steps with immediate feedback, and after each step was learned, the skill as a whole was learned. And in our simulation, we have a AI-controlled avatar with a speech recognition technology. Our participants could have a bit of a conversation with it, and the UI provided them with hints and feedback on the conversation they had. So overall, the experimental setup looks something like that. We had a entry test, which was phone conversation with an actor. Actor was an employee, participant was the manager. They had to work out some issues. Then there was an adaptation stage, then the training itself, and then the exit level, a second phone conversation with an actor. And the blind expert assessed the differences between the first and the second conversation as an educational result. And we looked at the EEG measurements of cognitive load during the training simulation specifically. And EEG recordings were done with Muse headband, fits nicely with HMD, and we measured frontal tetherime as the measure of cognitive load. As a result, we found that adding an adaptation phase actually improves the educational results, and adaptation phase reduces the cognitive load during the training. And as you can see, lower the cognitive load during the training is, better are the educational results. But differences in the dialogue simulations were not as important. Uh, uh, Specialized and generic adaptation groups did comparably well. And we hope that accounting for students' familiarity with virtual reality could make future results of VR education better and more consistent. Thank you for your attention.